Number 4a, this one is asking about distance. So distance takes into account the whole path. We have to add up the total distance traveled. So we went 50 meters to the east, and then we went 220 meters to the west, and then we went east again 30 meters. So we just have to add up all of the distances, 50 plus 220 plus 30, and we're going to get 300 meters. So distance takes into account the whole path traveled. Now 4b is asking for the displacement. This one just cares about the endpoints. So if we go back to our picture here, we started here. We went 50 to the right, 220 to the left, and then 30 to the right. So we ended up here. So we just need a distance between those two endpoints, between here and here. The easiest way to do that is to do 50 minus 220 and then add 30. And we'll get negative 140. So we ended to the left of the starting point. So that's why our displacement was negative. Let's do number 5. This one is asking for average velocity. So average velocity, we can go ahead and write down the equation, is going to be the total displacement divided by the total time. But this is one of those problems that has two segments. So we have a displacement here for the first part, delta x1, and then we have another displacement here for the second part of the trip. So the total displacement has to be the total displacement of both parts added together. And the total time also has to be the time of both segments added together. So we have the velocity here for the first part and the velocity for the second part. So what we need to do is find the times separately. So we go to the side here and we say that our time 1 is going to be equal to our displacement 1 divided by our average velocity 1. And this comes from just rearranging this equation here for average velocity. So we're going to plug in 1,000 and 90, and we're going to get a time. And then we're going to do the same thing for time 2. We're going to plug in delta x2 divided by v2. So we're going to plug in 1,000 divided by 60. I don't have my calculator handy with me right now, but you're going to get two different times here that you're going to plug in here in the denominator. And in the numerator, you're going to plug in 1,000 plus 1,000. And when you work it out, you should get 72 meters per second. The trick to this problem is to make sure that you don't just average V1 and V2 to get your final answer. There's no equation that says to get the average velocity that you can just average two velocities. You must always find the total displacement and the total time separately and then divide the two. Let's do 6 and 7. So this one we have a kinematic equation problem because we're given that the car starts from rest, so that's V initial here is 0, and this is VF here, 200 kilometers per hour, 4 seconds is the time. And we're looking for the acceleration. We have 3 variables, so we have to find a kinematic equation that has V initial, VF, T, and A. But before we do that, we want to go ahead and write down our givens. I'll go ahead and rewrite them because we want to make sure that we have converted everything. So this one is fine, V initial 0 is fine. But our VF, which is in 200 kilometers per hour here, we need to go ahead and convert that to meters per second. So we're going to have our conversion from kilometers to meters. We're going to have 1,000 meters is 1 kilometer. That will cancel out the kilometers. And then we have to get rid of those hours. So the hour has to be on top, and the seconds has to be on the bottom. And there are 3,600 seconds in 1 hour. And this number happens to be 55.6. I had this one memorized. So now it's in the correct units. And we have our time is 4 seconds. And we're looking for the acceleration. So a kinematic equation that has these 4 variables is going to be that first one. Vf is v initial plus at. And I like to cross out what's equal to 0. V initial is equal to 0. And now I can go ahead and solve for acceleration. It's going to be our final velocity divided by time. 55.6 divided by 4 is going to be about 13.9 meters per second squared. And one more, what's going to be the distance? Well, now we have 4 variables already. We have VO, VF, T, and A. So we can use any of the equations that has delta x in there, and we'll have enough information. So I'll go ahead and use this one because it doesn't require my acceleration value, which might be slightly rounded. So I'll use delta x is 1/2 v initial plus v final times time. We don't use this one as often, but it's perfectly valid. We can plug in v initial is 0, vf is 55.6, plug in our time of 4 seconds, divide everything by 2, and we will get 111 meters.